Problem number 7.4. Consider the set of column vectors defined by x, which is equal to x belongs to r power 3, which is 3-dimensional, and our vector is x1, x2 and x3, which equals 0, where x transpose is x1, x2, x3 transpose. Which of the following is true? We have 4 options. Option A is 1 minus 1 0 transpose 1 0 minus 1 is a basis. So it is a basis for subspace X. And option B is same vectors and is a linearly independent set but does not span X, therefore it is not a basis. So it is a not a basis. And in option A we have it is a basis, and option C is X is not a subspace for r power 3, and option D is none of the above. So our vector is x1 plus x2 plus x3 is equal to 0. Now 1 1 1, our vector will become 1 1 and 1, and our variables are x1, x2, x3, which will be equal to 0. Now this has rank 1, rank will become 1, and number of variable is 3. So nullity or free variable is 3 minus 1, which is 2. So our equation becomes, the equation is x1 plus x2 plus x3 is equal to 0. This becomes our equation 1. And let us take x2 as lambda and x3 as k, as we have two free variables, so we take two assumptions. Now x1 will become, from equation 1, x1 will become x1 plus lambda plus k equals 0. Then x1 will become lambda minus k. Now we will separate from their variables x1, x2, x3, which will be equal to, x1 is minus lambda minus k, x2 is lambda, and x3 is k. Now we separate variables. Lambda minus 1 1 0 plus k minus 1 0 1. Then our basis will become, basis B will become, let us take a set minus 1 1 0 and minus 1 0 1, which is equal to B. As dimension of vectors are 3, then our basis must contain 3 independent vectors, but our basis but our bases do not contain three independent vectors. That's why we can write B is a basis for subspace of a vector space R power 3. B equals, our vectors are -1, 1, 0 and -1, 0, 1 is a basis for subspace of R power 3. For a 3D vector space, it is a subspace. Finally, option A is correct.